Hello guys, you are welcome back to our abstract algebra tutorial. In today's tutorial, we want to look at some basic questions on the Chinese remainder theorem. And so we have our first question here, which says that if 12x is congruent to 3 mod 29, find x. So we have several ways of going about this question. And so if this question is given to you maybe in subjective or in objective, we have shortcuts of solving it, and we also have, you can also be restricted to use something other to solve this. So if you know how to find the inverses of congruent, what I'm talking about is probably a number that you can multiply. Let's say we have a number here 12 times x, and you know that there is a number that you can multiply by 12, and when you take mod 29 you get a remainder of 1, because 1 is always our identity element. And so when you get your 1, you know that that number is the inverse, because let's say you have 2 and you want a number that you can multiply by 2 to get 1, obviously that number should be half. By incongruencies, we are dealing with integers, so we will not be looking at numbers like half and other things. Okay, so that is not what we will be looking at, but that is just the idea about what congruencies are. Well, since this question is given to us in this form, and you can clearly see that on this side, this and this, they have a common factor, and so we can divide through by 3 here by 3, and we have 4x is congruent to 1 mod 29. So I'm going to pass through the shortcut of solving this, and the shortcut is that well, you see the number that is here, which is the remainder. I'm going to write it in the middle, and now I'll continue to add 29, which is the mod, to the right hand side of the number. So I'll have something like maybe 30, 59. If you add 29 again, that will be, I think, 8 or something. So 59 plus 29, you're getting 88, plus 29 again, you're getting 117 here. Now on the left hand side, we'll continue to subtract. So we are subtracting. So I'm subtracting 1, so I'll get negative 28. I'll subtract again. So 1 minus 29 minus 29, get negative 57, negative 86 in that order. But we are looking for a number that is closer to 0 in this sequence. And so if we look at the numbers, 28 is closer to 0 and it is divisible by 4. That is the idea. The idea is that we are looking for a number that is closer to 0 and is divisible by the number that is here. And so that is why we are listing all these numbers. So as you are listing the numbers, you should also be checking which number is divisible by the number that is on the left hand side of the congruency. So since negative 28 is divisible by 4, I'm going to replace the 1 here with negative 28. And so I'll now write my congruency as 4. Let me use a different color. I'll write it as 4x congruent to negative, I'm replacing it with 1 here, negative 28 mod 29, like this. So I can then divide here by 4 and divide here by 4, and that will mean that I have x congruent to negative 4 divided by this, I think you get 7 also, yeah, negative 7 mod 29, which is just Negative 7 mod 29 is the same as x. Congruent to, we just add 29 to 7, making 22 mod 29. And this is our final answer. That is all for this particular question. So you don't need to struggle to do anything. That is all. So this is our final answer. If it is in objective, this is a shortcut for you to do. But we also have a method we call Euclid's algorithm. Euclid's algorithm, which we can also use to solve this particular question. So sometimes you can be restricted to use the Euclid's algorithm to find the inverse of 12 first, after which they will then ask you to use it to then solve for the value of x. And so that one too is having its own method. So I'll stop here and we'll continue later. If you are first time watching this video, kindly subscribe to my channel. Thank you for your support.